Welcome to Data Structure course. Hello students, I am Swapnil Chaudhary. In my previous video, we learned searching techniques. The first one is a linear search, second one is a binary search, which we are learned linear search and binary search using array. And then we see the skip list concept, which is we implemented on linked list. From this session, we are going to see some sorting algorithm. So now we are going to see introduction to sorting. Introduction to sorting. Sorting is nothing but arranging the data in ascending or descending order. Okay. Sorting is nothing but arranging the data in ascending or descending order. The term sorting come into the picture as a human realize the importance of searching quickly. There are so many things in our life that we need to be searched for, like a particular record in a database, like roll number in a merit list, a particular telephone number in a telephone directory, a particular page in a book, and so on. All this would have been a mess if the data was kept unordered or unsorted. But fortunately, the concept of sorting comes into the existence. It makes easier for everyone to arrange the data in order, hence making it easier to search the data. So what is sorting? Sorting arrange data in a sequence which makes searching easier. Now, if you ask me how I will arrange the deck of shuffle card in order, I would say I will start by checking every card and make the deck as I move on. It can take me hour to arrange the deck in order, but that how I will do it. Well, thanks to God, computer doesn't work like this. Since the beginning of the programming age, computer scientists have been working on solving the problems of sorting by coming up various different algorithms to sort. Basically, the two main criteria to judge which algorithm is better than the other have been, the first thing, the time complexity and space complexity. Okay. There are different sorting algorithms like bubble sort, second, insertion sort, third, selection sort, then fourth quick sort, then fifth merge sort, sixth radix sort, seventh heap sort, and so on. So now onwards we are going to see all this sorting algorithm one by one. So let's start with a bubble sort. Let's start with a bubble sort. The bubble sort algorithm let's start with a bubble sort. Okay, the bubble sort is a simple algorithm which is used to sort a given set of n element provided in form of an array with n number of elements. Basically, bubble sort compares all the elements one by one and sort them based on their values. If the given array is to be sorted in ascending order, then the bubble sort will start by comparing the first element of the array with the second element. Suppose if you have an array having some elements like 108, 20, 99, 6 and 10. So this is what an array. So if you have unsorted array like this, then bubble sort will start by comparing the first element with the second element. If the first element greater than the second element, it will be swap the position of both. Then what happens? 20 will swap with this location and 108 swap with this location. And then move on to compare the second and third element, so on. If we have total n element, then we need to repeat this process n minus 1 time. If we have n element, then we need to repeat the same process n minus 1 time. It is known as bubble sort because with every completion of iteration, the largest element in the given array bubbles up toward the last place of largest element of the given array. Largest element, this is 108. This is largest element of the given array is bubble up toward the last place. This is what last place or highest index, just like water bubbles rise up to the water surface. Okay, so now we are going to see a small implementation of bubble sort. Okay, then we will see the example. Okay, so now what I'm going to do, I'm going to write the algorithm for or code snippet for bubble sort. So this is what the void bubble sort algorithm, and here I'm going to start with my code like integer I, j, and I have one more variable, that is temp, since I'm going to use swap algorithm here. Okay, now inside this for initialize I is equal to 0, I less than n, and I plus plus. Inside this for loop, I have one more for loop for j is equal to 0, j less than n minus I minus 1. Okay, what is j? J is less than n minus I minus 1. Okay, and j plus plus. End of this, closing of this for loop. And then what I'm going to do here, I'm going to check if array of j, if array of j is greater than array of I, or you can say array of j, here I'm using j's for loop now. So array of j is greater than array of j plus 1. Okay, array of j plus 1. If this condition is satisfied, then I'm going to swap, that is temp is equal to array of temp is equal to array of j, and then array of j is equal to array of j plus 1, and array of j plus 1 is equal to temp. Very simple logic. This is what swapping concept, swap. Okay, nothing else. End of this if loop, end of this for loop, end of this for loop, end of the bubble saw. Very simple code snippet. Okay, now let's check the same concept with this array. So here I'm going to write this array. So what is that? 108, 20, 99, 6 and 10. So this is what 0, 1, 2, 3 and 4. So size is what? An integer n is equal to what? 5. N is equal to what? 5. Okay, the size of array is what? Array is holding maximum 5 element. Okay, and this is what? Array. Okay, now for I is initialized to 0. Okay, so 0 is less than n. What is n? That is 5. Condition satisfied. It jumps to the for loop. Now j is equal to 0. J is initialized to 0. 0 is less than n. What is n? 5 minus I. What is I value? 0 minus 1. So that is 4. Okay, that is 4. So 0 is less than 4. Condition satisfied. It jumps to the if loop. For loop. Now inside the for loop, what I am going to check? Array of j. What is j's value? Initialize j to the 0. Okay, what is j's value? 0. J's value is what? J is equal to 0. Okay, now the array of j at 0th index, what we have? 108. 108 is greater than array of j plus 1. What is j? 0's value? J's value 0 plus 1, that is 1. So at the index 1 we have 20. Okay, so this condition is satisfied. 108 is greater than 20. 108 is greater than 20. So what we are going to do? We are going to swap them. So simply what happens? The array will change, like here comes 20, here comes 108, and the remaining array is as it is 99, 6 and 10. Now end of the if, end of the for loop, j plus plus. Now what is j's value? J's become 1. I's value is same, no change, since our inner for loop is continue. So j's value is 1 is less than 5. I's value 0 minus 1. Okay, so 0 minus 1 again. So what is this value? See, j's value is 1 and this is what? 4. Basically this is what? 4. Are you getting me? 5 minus 1. Since i's value is 0. I's value is 0. This is 1. So 5 minus 1, 4. So basically this is what? 4. Okay. Now 1 is less than 4. Condition satisfied. It jumps to the for loop. Then check. Now what is j's value? J's value is updated to the 1. So array of 1 position. So this is 1. Array of 1. So here your j is pointing. and j plus 1 is here. This is what j plus 1. Okay, so now check at jth position. What is that? 108 is greater than 99, condition satisfied. Greater than 99, condition satisfied. So what we are going to do? We are going to swap the positions. So the next updated array is what? The updated array is what? 20, 99, 108, 6 and 10. Now end of the inner for loop, j plus plus. J's value changed to the 2. J's value changed to the 2. Okay. So j will pointing to the index 2. So the 0, 1, 2, 3, 4. So now your j is this, and this is what? J plus 1. This is what? J plus 1. Now again 2, what is j's value? That is 2. 2 is less than 4, condition satisfied. Jump to the if loop, if array of j. What is j's value? That is 2. So j is pointing to 108 and j plus 1 is pointing to 6. So 108 is a greater than 6, condition satisfied. It will swap the position of array. So now here I am writing this array. So here comes your 20, here comes your 99, here comes your 6, and here comes your 108. And this is 10 as it is. 0, 1, 2, 3, 4. So now end of the if, end of the for loop, j plus plus. J's value becomes 3. J's value becomes 3. Now j is pointing to this index location. This is what your j plus 1, j plus 1. Okay. Now 3 is less than 4, condition satisfied. It will jump to the if loop. Now at j position, what is that? 108 is greater than 10. It is greater than 10, condition satisfied. It will swap the position. Now your final array, now your updated array is what? 20, 99, 6, 108. It is 10, and this is 108. Okay, so what happened here? I'm writing it again. So what is that? 20, 99, 6, and here comes your 10. So this 10 will swap with 108, and here comes your 108. So finally what happened? The largest element of this sequence is a bubble out. The largest element of this sequence is a bubble out. So that is why we call this algorithm is bubble sort. But still this array is not completely sorted. So what I'm going to do? End of the for loop, j plus plus, j's value become 4. J's value become 4. So 4 is less than 4, condition false. It will not jump to this for loop. End of the outer for loop. It will comes to the end of the outer for loop, I plus plus. Now I becomes 1. I become 1. Now j is initialized to 0 again. Okay, so 1 is less than 5, condition satisfied. It will jump to the inner for loop, and same process start from the 0th index again. So now what happened in ahead? I will explain. So 20, 99, 6, 10, and this is what? 108. Now here what happened? This 20 again, for inner for loop we started. 20 will going to compare with the 99. So 20 is less than 99. There is no change in an array. Then 20, then 99 will going to compare with 6. This 99 will going to compare with the 6, 10, 108. So what happened? 99 is a greater than, this 99 is a greater than 6. So we are going to swap it. So what happens? This 6. So basically then 99 will going to compare with this 6. So 6 will swap with this, 99 comes here. And the next step, this 99 is going to compare with a 10. So 99 is greater than 10, then 10 will be swapped with 99. So 26, this is 10, this is 99, and here comes your 108. So by default, the second largest element of this array is come bubble out at the top of the array. But still this array is not sorted. So what we are going to do? We are going to start with this for loop again. Now 20 is going to, you may go for that 99 compared with the 108, no issue. But we write this code snippet like that. This will not going to compare with the sorted element, the largest element will not going to compare with the others one. Okay. So now here what I am going to do? So again 20 will going to compare with the 6. 20 is greater than 6. Then we are going to swap their positions. So here comes 6, here comes 20, here comes 10, here comes 99, and here comes 108. Again this 20 will going to compare with a 10. What happened? Swap it. So here comes 6, here comes 10, here comes 20, here comes 99, here comes 108. You may go for this 20 is compared with the 99, 108. So it will not swap since 20 is less than these two numbers. Now again we are start with the starting of this 6 will going to compare with the 10, 20, 99. So now this array is what? Sorted array. So what happens? Why we call this algorithm as a bubble sort algorithm? Since at the first iteration, the most largest element is bubble out at the end of the highest index or end of the array. Then second largest, then third largest, then 10, so next largest, and then next largest. So in this way, we are get the sorted array. How we are get sorted array. So this is what a bubble sort algorithm. In your final examination, there may be question. Write and explain the algorithm for bubble sort. Okay, with example. So you may go for this algorithm and you may write like this step by step with justification. So this is what a bubble sort algorithm. So time required to sort the worst and average case is big O of n square. Big O of n square. So time complexity required to sort bubble sort using bubble sort algorithm, that is big O of n square. How it comes? So here very simple, we have two for loops, iterating loops. Okay. So now we are going to see insertion sort.